All right, I'm going to do a lesson on opcodes and operands to help you out with assignment 1. And one of the ones we do in class is 3 pecks of pickles, and I'm going to go ahead and do that for you and walk you through the process, and hopefully this will help you out. All right, so this is the 3 pecks challenge. Oops. Very similar to what you're going to be doing. Instead of pecks of pickled peppers. That's a tongue twister. You are going to be doing inches and feet, but similar, very similar to this. So you've been sold 2 bushels and 3 pecks of pickled peppers. If we know that there are 4 pecks in a bushel, then how many pecks of pickled peppers do we have? All right, so not that difficult math, so that comes out to 11, right? So you have 4 pecks. You have 2 bushels and 4 pecks per bushel, so that's 8, and then we add 3 to it, so it's not that difficult math. So the first thing you have to do is you have to put those into memory so that the computer can do something with it. And we use an opcode of input, and we sell it. Well, we want to input 2, and we want to put that into a memory location, so we're just going to put the memory location number 1. Doesn't matter where we put it. Right? The next number is the 3 for the 3 pecks. So I have input 3 M2, and then the last number we have to bring in is the 4, and we have input 4, and we'll put that into M3. All right, so now those are in. So that's the first part. And every problem that you do, including the homework assignment, is going to start out with inputting in the numbers. So you, for the homework, you're going to do so many feet and so many inches, and you have to figure out how many inches there are. So we know that there's 12 inches in a foot. So you have to input the number of inches into M1, input the number of feet into M2, and input 12, which is with the multiplier, into M3. So very similar. Once we get the numbers into memory, the next thing we have to do is send them to the central processing unit. And we do that using an opcode called move memory to register, MMR. So that's move memory to register. I have to tell it which memory location to move. So let's do M1 first. And what register to stick it in. And I'm going to stick it into R1. So that's going to be move M1 to register 1. All right, pretty easy. So I have to do the same thing with the other 2 numbers. I can't do anything with them until I get them up into a register. We never do it out of order. We don't input some stuff and then move some stuff and then do some math and then input more stuff and then move more stuff. We input all our numbers. We move all our numbers. So the next one, M2, and we'll stick that in R2, MMR, M3, R3. Now I have this instruction out here, move M1 to register 1. That's what we're doing there. But one thing you might find helpful is over here to document what's in R1. So in R1 now is the number 2 because we moved it from M1 to R1. And then this one is going to have the 3 in it. And then register 4, when you register 3, is going to have a 4 in it. So you see how that worked? So we took the 2 from M1 and put it into R1, so now R1 has 2 in it. And then the 3 in M2, put it in R2, and now it's got the 3 in there, so we can see these are the 3 numbers. Once I get it in, then I can start doing some math. So since I have 2 bushels, and I know that each of those bushels has 4 pecks, might as well multiply them first. So I'm going to use the opcode of mul, and then I'm going to say, well, what do I want to multiply? I can only add, subtract, multiply, divide registers. I can't do M's, just R's. So we're going to take the 2 that's in R1 and multiply it by the 4, which is in R3. All right, and then over here, to make it a little easier, we can say, okay, this is 2 times 4. All right, so that's what we've done for the first one, first piece of math. But the answer is 8, and the 8 is sitting in the accumulator, and we can't do math on things that are in the accumulator, so we have to move it out of the accumulator into a register so we can actually use that 8 in math. We use MAR to move the accumulator to a register, and then we just have to tell which register we want. And since I've already used 3 of them, this is going to go into R4. So now R4 has the number 8 in it, 2 times 4. So now I have to add that 8 to the free PEX, which is 3, and I'm done. All right, so the next thing I'm going to do is I'm going to add R2, which has the 3 in it, with R4, which has the 8 in it. All right, and then 8 and 3 is 11. So this is going to be 3 plus 8. That's done. All right, and once we get that answer 11, we have to do something with it. Now 11 is our final answer. So whenever we do our final answer, we're not going to put it into a register. We're going to stick it right back into memory. So we're going to use move accumulator to memory, MAM. And since we've used 1, 2, and 3, this will go into M4. And then we can halt the program. We're done. All right, so in M4 right now is the number 11. So you can see how that goes. Input into memory, move it to registers, do the math. Every time you do a piece of math, you're going to have to MAR it into a register, except when we do our final math. So when we get our final math, our final answer, we don't MAR it. We move it to a memory location. So now once we get it into memory 4, very easy. Now we can either print it to a printer or we can save it to a disk, whatever we want to do. M4 now has that number 11 in it. All right, so the next thing we want to do is we want to code this. And so I'm going to go ahead. This is going to be a long video, but at least we're going to do the whole thing together. So the next thing I'm going to do is I'm going to get HTML kit. So you have to download it, and it'll go into a folder called HTML kit, and in that kit has a folder called bin. And then I just double click on the htmlkit.exe, and that will open it up. Okay, when it gets opened, it's going to ask you some questions. Oh, it didn't ask me questions there, but if it does ask you questions, the answer to all the questions is no until it gets right here. I had previously opened it, that's why the questions were already answered. All right, so I want to go ahead and create a new file. And it puts a bunch of HTML on there. I need to get rid of all that. And if up here you can see a thing called objects, and then it's going to put these objects down here, and we want to use the JS because we're using JavaScript in this class. Alright, what if that for some reason you lose these tabs? Well, really all you really need to do is type in start script and end script. Alright, so you don't need all this JavaScript stuff here. It assumes JavaScript anyway. So you can just type it in. You don't even need this stuff here. So if you don't want to go ahead and hit that button, all you have to do is open script and close script. Alright, whoops. Let's go back to our notepad file then. Alright, so here's our notepad file. This is our source file. So the first thing we have to do when we're coding this is use the keyword, whoops, not uppercase though, var, which stands for variable, and I need places in memory. I need M1, I need M2, I need M3, I need M4. Notice I'm using all lowercase here. You know, you can use upper and lowercase down here, doesn't make a difference, but when you do in code, for these first ones, do it all lowercase. Alright, and then I use a semicolon at the end, and that's going to say that we're done with that line. Alright, so the next thing we're going to do is we're going to say I want to input into M1. So this is how we do that. We do a chant. We're going to say I have a place of memory called M1 that we just declared. I wish to assign to that place of memory the number 2. Notice we're using the equal sign. In JavaScript, the equal sign doesn't mean equal. It means assign to. So I'm going to say I have a place in memory called M2. I wish to assign to that place in memory the number 3. I'm done. I have a place in memory called M3. And I'm sorry, I can't make this any bigger as far as the text is concerned. And I'm going to assign to that place in memory the number 4. And you can see, so these are very similar. We don't have to move things into registers when we use JavaScript. Okay, JavaScript does that for us, so we have to do these first 3, which matches these first 3 right here. Okay, now we're ready to go ahead and do some math. And if you want, you can add a comment, doing math. And right here is what we're going to do. So you do 2 slashes in front, and that's going to make anything to the right of that a comment. All right, next line, I'm going to start doing my math, and I'm going to say I have a place in memory called M4. I wish to assign to that place in memory what's returned when I take M1 and multiply it by M3. What? So no registers. We don't do registers in there. Again, the register part of that is all done. That's one of the reasons why I do assembly language. JavaScript's actually doing all this for us, but so it's not magic. You can see what's going to happen when I do those 2 things. It's going to take those values, put them into registers, return the values to here, and then do the math. But I also have to add M2. So I could do this. Oops. M2. Because we can, in JavaScript, we can add and multiply as many numbers as we want. We don't have to do just 2. In opcodes and operands, it's just 2. Okay, so here's the issue. This is complex math because we're multiplying and we're adding. So it's going to multiply these 2, then add that one. So it's not such a big deal this time. But I have some examples we do in class where if we did a complex math like that, we'd end up with the wrong answer because we'd want to add first instead of multiplying. So this is a complex, so we don't do that. We say, okay, let's just multiply first and then add. So now I have a place in memory called M5. I wish to assign to that place in memory what's returned when I take what's already in M4 and add it to M2. So you can see instead of doing 1 line of code, I'm doing 2, which would seem like it'd be a lot more work. But it's not, because it keeps everything simple. And the more simple we keep things, the faster the code is rendered, and the less easier it is for us to find errors. Alright, so the only thing is I've added another M here, an M5, so I have to add that to the very top. So comma M5. And now I have to output. So you can't output assembly language or the ones we're doing here. This is just a thought process. So now we're going to do output. And for output, we have to use document .write. And then I have an open colon parentheses and a semicolon. Inside here has to be what it is I want to output. And I simply want to output whatever is going to be in M5. So I say M5. And then when I hit the preview on the bottom, it says 11. So it worked. So we got to be careful. I want whatever's in memory location number 5 here. If instead I put quotes around M5, then when I preview it, it would say M5 because I'm saying literally I want you to put M5 on the page. But when we use it without quotes, we're saying I want you to output whatever's in that memory location instead. All right, so very simple. Again, you're going to be doing a homework assignment. That homework assignment is going to be inches and feet instead of pecks and bushels. So very, very similar. So let's see if we can go ahead and get that done.